Welcome back to Practical Computer Security. This is lecture 2, in which we will talk about what is a computer, particularly interested in applications of basic concepts about computers to computer security. So, we will describe to you basic things about the architecture of every computer, and we will be concentrating on explaining the basic things about computers with the idea that there are important security consequences, computer security consequences in this. So we see here, we see the general architecture of a computer, and you see in this diagram that there is this circle says I/O for input and output, and then there is a box that says it's a CPU, and then there is another box that says memory. And these arrows indicate that each of these units of what makes up a complete computer can communicate information. The I/O can communicate to the CPU, and the CPU can communicate with memory. And so information can be passed to memory and back to CPU from memory, and similarly from I/O devices. Information can be passed to the CPU and back to the I/O device. I/O stands for input and output. At the hardware level, a computer can execute a certain finite set, a fixed set of very simple instructions. So, for example, add a signed integer stored in register A to a signed integer stored in register B, and store the result in register C. Registers are basically memory, which is in the CPU itself. Now, these things are encoded with binary. So, for example, the add instruction might have the 4 bits 0001, and register A may be then encoded as 001, and register B as 010, and register C as 011, and so that the machine instruction would look like the concatenation of these things. So 0001, 001 meaning register A, 010 meaning register B, store the result in register C, which is 011. Another simple instruction might be store register A into memory position some number like 57 or whatever. Another instruction might be load register A, what's in memory position 98. So each of these look like a bunch of zeros and ones, and then the computer interprets each of these parts as the instruction code, and then it may refer to some particular register from the CPU has some fixed number of such registers, which is memory in the CPU itself, and then memory has a very large number of memory positions which can store the contents of the register, and so information can be stored from the registers to memory and from memory to the registers, and so these load and store instructions do just that. It's not important for you to understand the exact details of this, except conceptually, and the idea that a computer can execute a certain number of simple instructions like that, and that the instruction itself is expressed as a bunch of bits. a sequence of such instructions encoded in binary with zeros and ones like that is called a machine language program. Now, the program is stored itself in memory, and after the computer is set up in the proper way with the program already stored in memory, basically the computer can do one and only one thing. It can execute the instructions of a program. Now, this has very important security implications. I ask you, can you think what security implication this might have? And so I'll give you a few seconds pause for thinking. Well, let's continue. So, what are the security implications? The security implications, one is that an evil hacker that tries to compromise your computer cannot do absolutely anything bad on your computer unless he or she manages to execute a program. Now, this program is called a malware. That is a computer program written with the explicit purpose of sabotaging your computer. And so this is in general called malware. Now, security implication number 2 is that the goal of computer security, therefore, is ensure that the computer executes only programs which are properly installed from authorized trusted sources. Okay, so the operating system which every computer has, like Windows or Unix or Linux or Mac OS, is itself a program. It's a very large program which facilitates the execution of certain standard functions. The program, an application program, plus the system software is what a computer normally looks like, and it appears to be more powerful than the hardware by itself. The hardware by itself only can do these little simple instructions, add and load and store and etc. that I already told you. But together with the system software, higher levels of concepts are implemented by the operating system. So in particular, one of the important things that the operating system implements is the idea that you can have a file system. That is, rather than raw I/O that happens between a device like a disk and the CPU, which just transfers bits again, these are organized by the operating system in a way that we can think of it as a file. Now, all of you have experience with using files because you have experience in using computers. And so the file actually gets a name and is stored in certain ways on the disk, and the operating system has ways to locate the various parts of the file. So then the actual transfer of information can be done from exactly the places where it is on the disk. Communication with the file system is done through I/O devices, and communication with devices like printers and hard disks and flash drives and other computers on the internet, etc. All of this is handled by the operating system in certain standard ways. When the operating system implements a file system, it implements something called processes, it implements something called tasks, also called threads, and the access to the network, to the internet, and virtual memory. So again, this has important security implications too. That's why I brought how a computer system is structured. And again, I give you a few seconds to think, well, what is the implication, the security implication of this? And so we'll pause for 3 or 4 seconds. Okay, so there is good news and there is bad news. The good news is the hardware plus the system software is actually more powerful than the hardware by itself. The hardware by itself can execute those very, very simple instructions. And now the hardware plus the operating system implements this much higher level concepts, which is processes and tasks and file system and so on. So this is the good news. The computer with the system software, this is why system software is written in the first place, appears to be more powerful than the naked hardware by itself. Okay, but what is the bad news? Well, the bad news is that the system software consists of millions of lines of code, and it is a fact that it is very, very hard to write such an enormous, large program with zero bugs, that is, with zero defects or flaws. And so, unfortunately, the operating system includes flaws because we cannot write, so far with the current technology, even the best programmers cannot write programs with zero flaws with millions of lines of code. Okay, so therefore, the bad news is that the operating system has bugs, and in particular those bugs can be exploited by evil hackers to do bad things to your computer. Okay, so I stop here with this segment, and we will continue our discussion in the next segment of this lecture. So I'll see you in the next segment.